So what are the basic elements found in your body? And once you have those basic elements, what does your body build with them? That's our next smaller topic. The elements that we'll be looking at are nitrogen, carbon, hydrogen, oxygen, phosphorus, and sulfur. And these are the building blocks of the macromolecules, or the things that make up the larger molecules in our bodies. And we'll be studying carbohydrates, lipids, proteins, and nucleic acids. The lipids, proteins, nucleic acids actually make up our bodies, and the carbohydrates contain the elements that our bodies need in order to get energy. A polymer is a larger unit made up of monomers, which is a smaller unit. For example, think of a brick house. Each individual brick would be a monomer, M-O-N-O-M-E-R, and all of the monomers put together would form a polymer, or the whole brick house. So the polymers that make up the body that we'll look at are carbohydrates, and the monomer is glucose. Proteins is a polymer, and the monomer that makes it up are amino acids. And nucleic acids have the monomer of a nucleotide. And we'll do an activity in class where we will identify different polymers and monomers in the classroom, just to make sure that you understand that concept. But these are the three main polymers that we'll be studying, and they're considered to be macromolecules, or very large molecules. We get most of our energy from carbohydrates. That's their primary purpose, is to give us energy, and we tend to eat a lot of carbs. If you're an athlete, you carb up the night before an athletic event, and the energy, of course, is stored in the bonds of glucose. The elements are carbon, hydrogen, and oxygen. Carbohydrate, right? It says it in the word, and so it's CHO, and the ratio is a 1 to 2 to 1 ratio of carbon to hydrogen to oxygen. Monosaccharides mean one sugar. Mono is one, saccharide is sugar. The three monosaccharides are glucose, found in plants, galactose in milk, and fructose is found in our fruits. Take a look at these pop beads. A monosaccharide would be one single unit, so it would be the single green pop bead that you see on your screen. So again, the monosaccharides are glucose, found in plants, galactose, found in milk, and fructose, found in fruits. Look again at the pop beads. A disaccharide would be two pop beads put together. So the yellow pop beads would be an example of a disaccharide. The disaccharides would be two sugars. Di means two, saccharide means sugar, would be sucrose and lactose. Look at the diagram again. So the disaccharide again would be two sugars, and it would be the two yellow pop beads, and that signifies a disaccharide. So again, the two disaccharides we're interested in are sucrose, which is just simple table sugar. You use that to make your cookies, and lactose is the sugar that's found in milk. Some people are lactose intolerant, which means they don't have the enzyme in order to break down lactose, and it stays as this large molecule in your gut, and it makes you feel uncomfortable until you can get it broken down. Polysaccharides are many sugars bonded together. Main purpose is to store energy for a short term, and that's why athletes carb up the night before, because they can store that, and then as they're running around on the field or whatever, it's released into monosaccharides and they can use it. So take a look at the pop beads again. A polysaccharide would be the long chain of pop beads. There's 1, 2, 3, 4 pop beads all in a row there. Those are polysaccharides. Potatoes are a good example of a starch. They have hundreds of glucose molecules all bonded together in a very, very long chain. So you have many monosaccharides making up one polysaccharide, and that means that you can store it a little bit longer and eventually break it down into smaller units. Cellulose is found in the wall of every single plant, and as you can see, it's very fibrous, and it's made up of hundreds of glucose molecules. And it's the fibrous part of this polysaccharide that helps the plant to stay upright. It's found in the stems of the plant. And so plants don't have bones, and it needs some fibrous, tough polysaccharide to help it stand upright. And so every single plant has a type of sugar in it. And this one is an example of a polysaccharide. So what's next? You now need to go to the website and look at dehydration synthesis and hydrolysis. It's a short YouTube video, so take a look at that.